Okay, WebEx link, let me first. Okay, guys. It is 5:35. We shall continue. Last pause.
Sir, sorry, I have some question.
Please.
Yeah. 那个 last class, I forgot to mark the attendance. Is there something I can do to save it?
Let me check because I've made a record. I have a recording session. So not to worry, I will go through the recording session.
Oh, thank you, sir.
Okay. Okay, just to info you that the attendance will be in the first week of my lecture. So first week of my lecture is on on 9th of November. Please check back the week 9th of November. I put all the attendance and also the meeting, our meeting. Okay, and last week recording session, I'm just start in, I think, half of the class, but I'm still learning how to download it and prepare it in the MP4 version. Hopefully by this week I can download it and I will put on the e-learning. Okay, for today's lecture, today's meeting, I have made the recording. Hopefully, if not by this week, maybe by next week, I can put it on the e-learning. Okay. Okay. Okay, so what else that we need to okay, let me share. Okay, we are still continuing with pointer. Okay, before I start, do you hear me clear?
Yes.
Yes.
And what else that I need? Mm. Okay, we shall continue. Okay, pointer. Okay, this actually is the main features, the most powerful features in the programming C or C++. Okay, with this, by having this feature, actually the programmer can manipulate. Okay, why we say manipulate? Because pointer is actually didn't contain the value. Actually, pointer is used to point where is the value, where is the variable that you want to use. So inside the pointer, it is the value of the pointer. I mean the content of the pointer is the address of the variable that you want to point. Okay. Okay. If you look in these examples, okay, this example we have a block diagram. We have an address here. Address. These are all the address. And this is the memory, the content. Okay, as we know, each location, one location require 8 bit, contain 8 bit. So in order to store integer, which is 4 byte, you require 4 location. Okay, 4 location. Okay, if we look here, if we declare a pointer, okay, we declare a pointer, then this contain actually is the address inside the memory. Start from the location 900E until 4 locations, since it is an integer type. So it is a location 9,000. Where it point, where is the 9,000 address? If you look here, this is 9,000. So it point to the sum. Sum, it is an integer. It is at address not 9,000, 900,000. Okay, so it means that 900,000,090 actually is the address of sum. Okay. Okay, the address is 32-bit. Okay, for example, in the example, it is a 32-bit platform. So each of these each digit are represented by hexadecimal. Okay, 16 base number. Okay. And as usual, the memory is 8-bit, 1 byte for each location. So mean this each location is 8-bit. Okay, this pointer that points to the variable. If you declare it to point to the sum, for examples. Okay, a pointer store a memory address. Mean the content of pointer is a memory address. It's the address. It's not the value. Okay, why we require these features? Because you can use it, I mean, to point to the variable. Okay, later on maybe we can appreciate if we can use it in several occasions. Okay. Okay, this is how we can declare the pointer in this example. The pointer name is PTR. Okay, you can type such as this type. We refer to data type. Okay, it can be integer, short, constant, character, double, float. Okay, this is the type. You have a star, PTR. Or you can arrange, you can put a syntax such as you put the type, data type, put a star, and then space PTR. Also, you can put a star between the type and the name with space. Okay, this all syntax is valid. Okay, it can be used in the C++ or C. But if you're going to choose any of these, it is good to maintain, to make it constant, to make it consistent throughout your programming. So it is easier for you yourself to understand, to make programming be readable, and also for others. Okay. Okay, this is an example. You have integer star IPTR. So you declare a pointer. The name of the pointer is IPTR. Okay, and it is an integer type. Okay, you can also put others variable also. Okay, such as the second examples, which this variable also is an integer type. You can mix it together, put in a single line. Okay, where here you look here based on here, P1 is considered as an integer pointer, while P2 is just an integer. It's not a pointer. It's just a variable integer type. Okay. Also, you can use double. Then you have space. You put star, and then you have space, and you put dptr, the name of the pointer. So in this example, dptr also considered as a pointer, which it point to a double pointer. Okay, usually we use p or ptr as a prefix or suffix. For example, IPTR, APTR as a name of convention. It is not compulsory. Means it is good if you use it, but it's not compulsory. It didn't, if you compile with other than being given, also valid, it can be compiled. But it is good if you have, if you use the consistent throughout your code, throughout your programming. It is good to have such of consistency. Okay, rather than you make a interchange between the pointer and the variables. Okay. A pointer initialization of pointer via address of operator. Okay, how do we want to use? Okay, how we want to use it? Okay, first of all, in the first line, we declare and initialize number as an integer, where we assign 88 to be as a number variable. Okay, number is data type integer, which contain 88. While we declare p number as a pointer. Okay, at this point, actually, we just make the declaration. Okay, we just make declaration, we just declare. And it is point to an integer. Okay. And then we can assign the address of the number to P number pointer. Okay, this you make assign, you initialize the pointer. So the pointer initialization, the pointer P number is equal to an operator number, where an operator actually refer to address of operator. This is address of number. Okay, if you look here, this is an initial pointer variable. This is the what we call the content of the operator, the content of the pointer. Okay, this is the pointer which we are not yet known the address. Actually, the address is known when you compile and then you what we call it compile to get absolute object file. Absolute object file means that you put already the address. Okay, this is an integer pointer variable contain a memory address. This contain what is the value? Actually, is a memory address pointing to the integer value. Integer value, okay? And at this particular address, okay, the one that be in the pointer actually is a variable number. The content of this variable number is 88. Okay, where an integer variable contain an integer value. And this address, the place of this variable is actually in the pointer. Okay, it makes so sometimes it's quite I mean difficult to understand it, but for the sake of use to the application, I think it's quite helpful a lot, okay? Especially when you apply it to the embedded system, and we know the embedded system has a limited resources, especially memory. So later on, we are going to look at how we can utilize this. Okay, what else that we know, we need to know? Okay, this is the name of the pointer. It is a type integer, and this address we not sure, but the content of this pointer is definitely the number of the address for the variable number. Okay, so this is how we going to initialize the pointer. We use an operator with the variables. An operator means that address of the variable number. In this example, is number. Okay, this is how you assign. So after you execute this instruction, actually this value 0, 2, 2, C, C, E, C will be placed into the pointer, which the location we are not sure. Okay, this one we cannot confirm, but the content of the P number is this address. The variable number, address. Okay, address. We have to, okay, this is what we mean by address. This is the content. Okay. Okay. Okay, there are several ways to also to declare and assign. Okay, in this example, if you look, we we have a number with integer type, a variable number with integer type. We assign it with 88. Okay, and P number we declare it as a pointer, and in the same line also we use it to assign, to initialize, to point to the number. Okay, we have this, the AND operator refer to address of the variable. Okay. Okay. Next. Okay. Actually, this code and this code have a same effect. It has a same effect. And then when you change, okay, if you put star P number to the pointer, means that the content is not the address. Okay. If only P number, then it refer to the address. But if you put star, means that this is the value, the variable that you point, the value of that variable that you are pointed. Okay. We change the value to where the pointer is pointed, number, and now number is 99. So it will change as well as the variable number. Okay. It also make change to the variable number. Okay, you cannot do like this. Why? If you look, the first one, you hold on. Anyone, Yan Shunzi, do you have anything to speak?
No, doctor.
Because while I open the sharing, I cannot see the chat. Okay, okay. For my attendance, there were no password. You don't need, you just mark. Okay, so why we cannot use such as this line? If you look, we have the first line is correct. You initialize, you declare, you assign the number type integer with 88. The second one is correct when you declare the pointer. But the third one, after you declare, if you want to use it or you want to make the changes to the pointer, to the variable that you want to point, you need to initialize it first. You need to declare, you need to initialize. Because after this, after you execute the second instruction, you are not initialized yet to point where. So it's going to cause an error because you are not you are not telling the processor to this pointer to point to which variables. Okay, and suddenly you use it. You make changes to where actually, because you are not initialize it yet. So this will cause an error. Okay, this code compile fine, but will give you a runtime error because the syntax is correct. All the syntax is correct. Because the pointer is not initialized. Instead, then you can choose to use such as this. Okay, you declare integer, assign it with 88. You declare the pointer and then assign the pointer to point to where, and then you can use it. Okay. Actually, this code and this code are the same. Okay, class. Do you get it? Can you understand? Do you have any question? If not, I would like to share you. Okay, anyone have download the Visual Basic? I don't mind if you can, if you have any other programming. In fact, in the Bilbado also you can choose. I don't have the Bilbado board, and I also don't have I didn't install the Bilbado SDK. But our scope, okay, my part is only to give a talk about the C programming, C and C++ programming. Okay, I think I have made the pointer. Let me try, because this is the first time I've been used. After I mean, install the Visual Basic in my new PC. Okay, this is the one that we have discussed before this. Okay, I hope you understand how you can debug, you make a debug. Okay, it is crucial, I think, for any kind of, especially for the software, it's much easier to debug. There are also debugging for the hardware, but it's much more complicated compared to debug in the software. Okay, there is an error. Okay, can you find any error here?
Hello, sir. Is there a main function?
Okay, okay. Okay, what we can do is, Let me use the form. Push. Hold on. Oh, sorry. Never mind. Let me check back. So what else? What? Govin. Value. Okay, this should not be like this. Uh, I forget to, where can we put the head watch? Govin? Is it? Head watch, head watch. Where is the head watch? Because it's just this install. I just install it. But debug. Let me debug. Oh, it's not yet. Okay, I'm sorry. That's why. Okay, if you look here, guys, are you still with me? Guys? Okay.
Yes, Doctor. Okay.
Okay, if you look here, the first code, we assign number, integer type, a variable number, integer type, where we initialize it with 88. Okay, and then we declare p number as integer. So if you look here, the number is 88. But the p number, we currently are not execute this instruction yet. So the value is not, is not valid. Okay, let me continue. Okay, currently we stop at here, we halt at here. So we have execute this p number, and we assign it to point to the number. So if you look here, the address of the number and p number should be the same. This is address of. When we put n number, okay, n number, it means the address of the variable numbers. And since we assign, since we declare, we assign the p number pointer to point to number, so the number should be the same. Okay. Okay, after we execute this instruction, now the number also going to change since we execute the pointer number. We change the pointer to the number with 99. Okay. Okay, this I'm going to discuss it later. Okay. Okay, this is actually the same code. The only thing we save the declaration and initialization. Okay, we declare and initialize in the same line, while this it is separate line. Okay, the impact is the effect is the same. Okay. What we need to know about the number. Pointer has a type 2. Okay, you cannot mix up. When you declare an integer, I, where the pointer want to point to that particular variable, it should be in the same type. Okay, for example, D is a double. Pointer to D need to be double as well. Okay, then we can point. We can change the address stored in the pointer during the runtime. Okay. Currently, before this, IPTR is point to I, and then we need IPTR to point to some others variable, but this variable need to be the same type as well. Okay. If the pointer is declared as an integer, so J also need to be integer. Okay, so error is going to be error if you declare a pointer with different variable to point, data type or variable to point. In this example, if you look D, you have declared it as double. So you cannot use IPTR, the pointer of integer, to point to double. Okay, same as if you declare the pointer double, you cannot point to integer. Or you cannot use pointer, since the pointer, the content of the pointer is the address, it's not the value. Okay, you cannot use it to get the value. This means that it is a value of I, 88. Okay, so you need to make it as a address of I, address of this location, these variables. Okay, then it is it can be compiled. Okay, it's not a value. This IPTR, since you declare it is a pointer, so the content of IPTR is an address. But if you put star IPTR, then it's considered as a pointer to I. Then it is okay to use it. If IPTR means that it is a pointer. Okay, this is one of the example of the pointer. Okay, you have a num variable type integer, which you initialize the value of 10. Okay, then you want to print, okay, print of variable number to decimal, okay, and then the address variable, you print the address of, you have to put the sign, the and operator in front. So what happened actually? Okay, this is a variable num. The value of the variable is 10. Okay, the content of the variable. But the address of the variable, since you put address of, then it will take this number. Okay, this is the address. Okay, when you execute the instruction, it will mention address of variable number is, you put it as address of variables. Okay, class? Is it clear? Okay. So what? Okay. Okay, this is another examples. Integer number, you put the content, you declare and initialize the variable number with data type integer with 10. Okay, and then you declare a pointer. You assign the address of num to the pointer. Okay, this is one way of addressing. Okay, and then when you print, it will print the address of the variables. Actually, the address is the same as in the previous slide for the address. This is the other way of to write the code. Okay, there are several ways. For me, I think it's not necessarily the one that I put can be only be used. You can have some other kinds of way to write the code, okay, especially when you go with the dynamic memory allocation and so on. But if you are going to use the way that I'm giving the talk, then you can refer to this slide. Okay, okay, this is another examples. Okay, you have a pointer type integer that can hold the address of an integer type. Okay, this is a pointer, and then point to integer type of variables. You have variable the integer data type where you assign it with 10. Okay, assigning the address of the variables. Okay, P, okay, the pointer is equal to address of, because P is the content of the pointer. So the content of the pointer is address of. Okay. So variable value, the output will be 10. Value of variable. Okay, if you put star P means that it is the content of the pointer data variable that you point. This going to print the what? Address of address. This also address. This also address. Okay. For this point to it is the same as the next line. Okay. This value should be the same as the next line. Okay, as I mentioned, the output, the first one is variable. Okay, 10. Since this is a pointer, content of the variable. If you put stop P, so it's going to be 10. And then you have address of that variables. Okay, this is the address. Same, if you read only P, it means the address. Address. And then address of the pointer, also the address. But it's not the same as the previous two line. Okay, it's not the same as the previous two line. Okay, any question? Okay, if you don't have any question, okay, now we look at the what we have write before, the code that we have write. Okay, this is the address of the variable. Okay, we have variable at this address, and inside the variable, the content is 10. And the address of pointer, this is the address of pointer below, and the content of the pointer is the address of the variables. Okay, so P is the pointer that store the address of the variable var. The data type of the pointer and the variable var must be matched. Okay, because an integer pointer can only hold the address of integer variables. Okay. Okay. Do you have any question? Guys, do you have any question? Okay, if you don't have, we continue with reference variable, or we call it as reference. Okay, and we try to look at the examples. I mean, the difference between this reference and pointer. Okay, it is an alias or an alternate name to an existing variables. You have a variable, then you can have the reference of that particular variables. Okay, I mean, if you want to make, you want to be more understandable in the Malaysia culture, okay, we can have this kind of similarity. If you make Ali as a reference to Bakar, means that it is the same person, but with different names. Okay, you can call Ali and also you can call Bakar. It's the same person. We put it as alias Ali or Bakar, and this is valid. Okay, in the IC, in the identification card, it is valid. I think maybe some of you have some, experience with this. Okay, you know somebody with the same person, but it have different names. Okay, this also can be applied to programming. Okay, we can apply this also to programming. Okay, the main purpose that you want to use this reference, okay, you want to pass by reference to a function. Okay, so the function works on the original copy rather than it works in the original copy instead of a clone copy, which is passed by value, where any changes inside that particular function will be reflected as well as outside the function. Okay. Now, okay, let me see the example and how we can use it, how we want to address it. Okay, in order to have a reference, we are going to use the AND operator. AND operator means that address of operator. And that is applied in the expression. Okay, we have learned before this. When we have a pointer and we want to assign a pointer to point to particular variable, then we put an operator. This is for pointer. Okay, the AND operator is the right hand side of the equation of the syntax, but when we have the AND operator on the left side, okay, we use it for the aliasing, okay, to provide another name or another reference, or we can call it alias to the existing variables. Okay, how do you want to assign it, or what is the syntax to be used? Okay, this example show 3 way of the syntax to have a reference. Okay, the first one, if you look, you need to have a same data type. Okay, you have a type, and then you have the AND operator, and you give the new name for the existing name variables. Where the AND operator is new, next to the new name of that particular variables. Okay, here. And then you can have near to data type. Also, you can have in between, space between the type of data and the name, the new name of that variables. The right hand side is all the existing name, the one that you want to copy. Okay, if you look here in the examples, you have integer number, you declare the variable, you assign it with 88 with data type integer. And if you want to make a reference, okay, integer, you put the AND operator, and the name that you want to copy, you are going to use it later. Okay, the new name. And then equal to the other side of the syntax. The right hand side should be the name of the variable. Okay, so in this case, you declare a reference to the variable number, okay, where both reference, ref number and number actually have the same value. It is 88. If we're going to change the value of the number after the above line, okay, after you declare the reference and you assign it, and then you change the reference number, okay, you change the number also, it's going to change. Okay, for example, you put 99, the reference number also going to be changed to 99. See, similarly, if you change the ref number to 50, after you execute this line, the number, the above line, the number will be changed also to 50. So it's going to be the same. Okay, class. Any question? Guys?
Sir?
Yes, please.
Sir, like the last line, if different number, like int number is equal to 99 and int and ref number is equal to 50. So the last output will be 50, not 99.
Yes.
Okay.
If after this
This line.
syntax, you put a number, you change to 99. Okay, later you change the ref number to 50. So all the ref and ref number and number going to be 50.
50. Oh,
Yes.
okay. Understand.
Okay.
Okay, thank you.
Either of the ref number or number you change, it will affect both of them. It's going to
Oh,
be the same.
oh. Okay, I understand. Thank you.
The purpose of having reference, because you don't want to use another variable inside the
Inside the
function.
value function. Oh.
So it means if you change in the function, it will reflect also at global or static variables.
Global or static variable.
That is one of the purpose that we want to use the reference.
Global or static variable. Okay. Okay, understand.
Okay, good. Nur Hazaf.
Yeah,
Okay, can we have break for 5 minutes? 5 minutes break.
yeah, can.
Okay, 5 minutes.
Okay, Doctor.
Okay. Okay, class, I have a project here which example of how we use the reference, how we look at pattern reference. Oops. Okay, I cannot open it. Not sure why. Project reference. Oops. Project Okay, sorry, I cannot open. I'm not sure why. Close this and we continue. I think I have the, never mind, we look at, okay, as reference can be used in C and C++. Both of the programming can use the reference. So what is the difference between reference and a pointer? Okay, once you make a reference, it can only assign to a single variables. Okay, you can assign or declare it to a variable where you cannot reassign it. You cannot redeclare. If you want to assign to another variable, then you need to make another reference, okay, to another variables. While a pointer, since a pointer is assigned to an address, so you can reassign to another address, which another address is another variables. As we know that when you declare a variable, especially a global variable or static variable, it require one location in the memory, and that location is not changed. Okay, it is static. Okay, as we in our first uh, lecture last week, we have discussed about static, stack, and heap kind of memory that we can have. So for variable, it is a static. When you declare it, it will be fixed in the runtime. What I mean, when you run your project, when you run your program, it will be available throughout the running time. It is always be available in the running time. Okay, to assign an address of a variable to a pointer, you need to use the address of operator n. And to get a value, okay, which pointed by a pointer, then we need to use a differencing. Okay, the differencing means that this stop differencing operator. Called some of the reference use differencings to mean a stop. So for example, you have an integer and then you assign the integer. Okay, this is you declare and you assign the pointer. Then in order to get the number, you need to put differencing. This is what we mean differencings. Okay, it means that it is a value that you take. If you put if you didn't put the differencing, it means the address. If you put the differences, it means that it is a value that you are taking the value, the number of the variable that you get from. Okay. To assign an address of variable to a reference, you don't need an address operator. Okay. No address operator that you use. Okay. To get the value of reference, no differencing operator that you use. You don't use this. Okay, if you use, okay, let's say this is the integer variable number, the integer data type, you assign it with 88, and then you declare it is a reference. If you want to get, you just put reference number, because this is the value of the variables. It's not the address. Okay, so you don't use the differencing operator. So directly you just put, okay, or you can put a number itself. Okay, so number is same as reference number. It's not a pointer. Okay, class. Get me? Any question? Okay, any question? I would like to try one more time. I'm not sure what is the problem with my. Still, I cannot get it. Why? Okay, never mind. So, class, do you have anything to ask? Okay. Now we look at what is the common mistake that we always do. Okay, when you declare integer and then you declare a pointer, variable, and a pointer. Okay. Variable, a pointer is not the same as variable. A pointer is the address, variable is the value. Okay. The differencing operator, when you put in a pointer, it means a value. So it's not the same as address of. If you don't have the differencing, then it will be the same. It is valid, but in this case, it's not valid. Okay. An operator with the variable is an address, while differencing pointer is the value that's stored in this address. So the correct way, variable, okay, address of. This is a pointer. Pointer, it is the address of the variables. The differencing of pointer is the value. Okay, it is correct. Okay, just be careful with the how we write the codes. Sometimes it's look correct, and it is some of the syntax when you write it can be compiled, but when on the runtime it will cause an error. Okay, class, do you have any question?
No question.
If no question yet, then we shall go for my next lecture. I think I didn't put yet the lecture, the notes. I will put it later. Okay, this is the dynamic memory allocation. It relates directly with what we have go through before this. So what is dynamic memory allocation? It means that in the beginning, when you run your program, it's not available yet, it's not be assigned yet. Okay, it be identified, it been determined to be used, the resources, use the memory when it is run. Okay, when you declare a static, it's already available when you run it. But dynamic memory allocation, it can be use the resources and it can be removed. But for static, no, you cannot remove it. It will be throughout all the runtime, all the time. Okay. We continue about the array currently specific to C++. Okay, in order to, it is useful to understand about the array if you are going to use the dynamic memory allocation, or otherwise it's not useful because it will be the same. Okay, if let's say you don't use the array, you only declare one location of one variable for to use as a dynamic memory allocation, so it's quite wasted. Okay, it's quite wasted. So in order to use the dynamic memory allocation, we need to understand about array. So this part in the beginning, we are going to study about array. We need to know about array. Okay. Okay, pointer together with new and delete. New and delete can be used to allocate the memory. Okay, unless when you run new and then you start to allocate the memory, or otherwise it's not. Okay, for dynamic memory allocation, we start with C++. Later on, we look at the C programming for dynamic memory allocation. Okay, can be used to allocate a memory during the runtime. That's what I mean during the runtime. It means it is dynamic. Okay, which we consider it into the heap of the memory. Okay, heap of the memory. Integer number. Okay, previously we looked at integer number. We declare a variable number with integer data type, and we assign a value of 88. And then we declare p number as a pointer, and we assign a pointer to point to the variable number. Okay, so this we call it a static. Once you do it, means that it will be available throughout the runtime. You cannot remove it. So for a single variable using dynamic memory allocation, first you need to declare a pointer. Okay, this is, I mean, we have looked into this before. Integer and then star P2 means that we declare this as a pointer. Then you have to put P2 new integer. So the name, same data type. Then you initialize this pointer to be dynamically. An address is assigned to the pointer. And then in order to put a value, since it is a pointer, you want to put a value, then you put differencing star P2 and put a value. Okay, change the value where P2 is pointed to 99. Okay, where equal to 99, P2, which is an address, will be renamed. So if we print, if we run the program, address of the pointer, okay, you want to print this out with P2 when you want to get the value of this pointer, which is point to, just put differencing. And in order to remove it, when you don't want to use that particular location as memory for a pointer P2, then you need to put delete P2. So delete P2 means that it will destroy the pointer. Destroy or remove. It's not, the location is not reserved to the P2. Okay, that is the purpose of have dynamic memory allocation. But it is a wasteful unless you have a huge number of variables that you want to use dynamically in a single. So that's why we need to use the array. If we can use the array, then you can utilize the resources. Okay, class. Any question? Okay, if not, I'm going to stop now. Class, we are stopped now.
Yes, sir.
Okay, guys, are you with me?
Yes, sir.
Okay. Okay. Okay, just now I think I have a problem with my Visual Studio. So I would like to open and to run the reference. Okay. Okay, if you look here, it is in the notes. We declare the number, which is integer data type, and we assign it with 88. And then we have a reference to a number. The name is reference number. So it means that it is the reference to integer number. Okay, now we try to rebuild. Then we try to run it. Okay, we stop. We only execute the first instruction. So it will give 88, the value of number, the variable number, which is integer type. Then when we step over, we declare a reference number is a reference to number. So in that case, the value will be the same. If I'm going to change a number to become 21, okay, after I execute this instruction, okay, the reference number also will be changed to 31. Okay. If I change the reference number to 56, okay, the number also going to change to 56. Okay, it will be the same. Okay, as we know that we can only assign, once we assign the reference to a particular variables, we cannot reassign the reference to other variables. Okay, for example, in this, let me clean first the solution. Okay, now I'm going to, okay, when we try to rebuild, so there will be an error here. Okay. because we declare and initialize another variables, and we use the same reference number to another variable. It's not possible. Okay, we cannot compile this. Okay. Okay, do you got it? Okay, now we shall continue with dynamic memory allocation. Okay, for a single variable using dynamic memory allocation. Okay, this is the syntax. You declare as a pointer, then you initialize this pointer to be a dynamic memory allocation. Okay, an address is assigned to the pointer. And then you can change the value. If you want to change the value of the pointer, okay, this is a syntax. You need to put a different things. 99. So you put a value here. Okay. And then if you don't want to use the dynamic memory allocation, you want to delete it, you want to remove it, you have to type, this is the syntax. Okay, just delete P2. Then it will remove from the memory. Okay, it's not available. Okay, this is for a single value, single variables. Okay, and it is not, as I mentioned, it is a waste. It's not utilized unless you use the array. Okay. Okay. In this example, we look at we want to make an array. I presume that all of you know. This is a basic understanding of C++, an array. This is one dimensional array. Okay. If you want to declare it as a dynamic memory allocation, okay, this is how you do it. Integer star A, and then is equal to new integer and value, the numbers of array, the members of array. In here it is 10. So how do you want to access it? You access it using the normal addressing. So if you want to access the first numbers, the first value in the array, just put A, 0, then you access, you put it 9. Okay, you can also access such as this. Okay, you want a variable Z to be a value of the array at member 9s. Okay, so in this case, you can have a lot. Okay, you can make one dimensional, which is 1000. So you use 1000 location. Okay, if you calculate, for example, integer, it is a 4 byte. It requires 4 byte for a single integer. If you put in the example for 10, so it means it will use 40 location. It will assign 40 location for this A dynamic memory allocation. Okay, for T, because integer is a 4 byte. So a single location require 1 byte. So for one integer, it require 4 byte. So in total, if you have 10, it means that it will use 40 location. And how you going to delete for one-dimensional array is just you just have a syntax delete in bracket A. It means that it will release. So that particular location now, it can be used for other purposes. Okay, this is during the runtime. So you can imagine how you can dynamically use the resources. Okay, you can use for particular image, for example. After you're done with that image, you can remove the location for locate the image to use for another image. Okay. And this is for 2D array, two-dimensional array. This is the syntax. Okay. Since two-dimensional, you require you need to declare it twice. Okay. This is the syntax. Okay, integer, you have to put 2 star B. Okay, now this is the two-dimensional array, B array. Let's say you want to make it as 5 multiplied by 6 array of B. So the first one, you need to have 2 star, new integer star, and in bracket 5. And next, you need to have a for loop. For each this element 5, you require 6. For each of these 5, you require 6. So that's why you need a for loop iteration for 5. This should be the same. Okay, the value. Okay. You need a for loop. Okay. For 5 iteration, where you declare B, and then you have to put in bracket I. Okay, so I will be between 0 until 5. So it will be up to 4. So if you include 0, it means that it's going to have 5 members. It's 0, 1, 2, 3, 4. So you have 5 members. And then you put new integer and then in bracket 6. For each of these, the first dimension 5, you put 6. Okay, this is for C++, guys. Okay, this is for C++. Okay, so it must be similar for the first syntax and the second syntax. The first syntax is to declare 5, and the second syntax is each of these 5 requires 6. So these two need to be similar for the first dimension. And then you have the second dimension, 6. Okay. Okay, you have to take note how many new for 2D. Okay, should be 2. Okay, new is what we call it, a code to generate a dynamic memory allocation. Okay, you need 2. And then you need to look at the star, how many star. So in the beginning you have 2, and then you have 1, and then you have no. There will be no star at the last one for the second dimension called declaration. Okay. And okay, how you can use it? You can use it in a normal way. Even if you don't use in the dynamic memory allocation, it will be the same. Okay. For example, if you want to access array B, where the first element of the first dimension and the third element of the second dimension, and you put the value 22. Okay, this is how you use it. I think this is a normal way of using it, even if not in the dynamic memory allocation. And how you delete it? Okay, first of all, you need to delete the you need to delete the second dimension. Okay, so you need to have a loop for each of the first dimension, because second dimension is depend on the first dimension members. Okay, so this one also need to be the same. Okay, and then you delete B in bracket I. So each of these will be deleted. Each of the second dimension will be deleted. And then you after came out from the loop, you delete B. This is how you remove all the memory location inside there for B. Okay, second delete, destroy the B. So you don't need, for this part you don't need, because you already use for the second dimension here. Okay, this is for 2. Actually, the arrangement for the 3-dimensional array is about the similar. It's about the same. Okay, for example, in these examples, we have a 3D array C, which we have 5, 6, and 12. Okay, first, how we declare it. Okay, if you look back here, integer 2, it need to store for the 2D. Okay, so in here we require, because this is 3D, so we require 3. Okay, C equal to new, then integer 2 star, and then this is the first dimension. Okay, and then you need to have a for loop. For loop for the second dimension. Okay, second dimension you require 6. Okay, and this 6 you require 12. In this 6th dimension you require 12 members. Okay, so you have 3, 2, 1, and then you don't have any star here. Okay, this is for the 3rd dimension. So the 3rd dimension, it has 12 members for 6 array. And how to use, same as the second, same as 2-dimensional array. Okay, you just use it directly. Okay, and how you delete it. Okay, as I mentioned, we look at this star. It depends on the numbers of dimensions. So if you have 3 dimensions, then you need to have 3 in the beginning, and then 2, 1, and until 0. Okay, same as here, you require 2. This is for 2 dimension, 2, 1, 0. Okay, and then you, because 3-dimensional array, then you require 3 new to create 3 new for this 3D. Okay, 1, 2, 3. Okay, when you want to delete it, okay, in the beginning it is the you delete 5, and then 6. Okay, this is what we call nested for loop. Within the first 5, you have 6. Okay. And this is the nested, you need to have I and J, because when you declare, you have I and J for the third dimension. And then you delete out of the second for loop, you delete the 5, and then you delete out of the for loop, you delete C. Actually, there are many ways, I think, to declare and to delete the dynamic memory allocation. But this is one of the way, and I found it more easy to understand. I think it's quite difficult to find a reference which clearly describe of dynamic memory allocation line by line. It's difficult. I think it's sometimes it's made confused. You are getting confused, especially when you want to declare and you want to delete. Okay, and you have to really careful to if let's say you you follow certain method, you have to follow it carefully, because when you know the dynamic memory allocation normally use a huge amount of resources, okay, memory. So the way you declare and the way you delete it, remove it, should be matched, or otherwise it, because in C++, you can resize it, but that is out of our scope. We are not discussing about resize the dynamic memory allocation. So what we intend to do is to create and to delete with the same amount. We don't want to resize it. Okay, you can resize, you can delete part of the dynamic memory allocation and leave the other part. It is possible to do it, but it's not in our scope. Okay, our scope, we just focus on when we create, we delete all that we have created. Okay, same as we use nested loop, same when we declare, when we delete also, we require to use the nested loop. Okay, and then the last delete. Okay, this is the syntax. There are some other methods where you can use, but if you use that particular method, sometimes it's not, not suitable for the other method to use to delete it, because this is the way of you arrange the array dimension. Okay, 5, 6, 12. Okay, there are some other way where you can delete in the other way around. Okay, it's not the same as what we have syntax here. Okay, class. Any question? Hello?
Sir?
Okay.
So the last will be all the value and address will be delete, because delete C.
Yes. Actually, this is the syntax. If you use this syntax, it means that you are going to remove everything,
Oh.
the one that you create. There are some other way where you only delete some part of it because you want to use the other part, but that is not in our scope. So we are not going to that particular discussion. If you follow this, it means that you are going to delete everything that you have created.
That's mean dynamic memory allocation is we input the value and then we delete the value. It's just like array, in array we can we alter the value there.
Yes. Okay. This is during the runtime. It means that it can be created during the runtime. If you use ordinary array, when you run your program, it already been there. It already used the memory. Okay, it's already fixed until the end of the memory. But if you use dynamic memory allocation, you can create it at any time, at any point on the runtime. Okay, let's say after half of the code execution, then you start to create a dynamic memory allocation. You use certain part of memory. And then after you use it, then you can remove it. You remove the memory for other purposes to use the memory. That's why we call it dynamic.
Oh, right. So dynamic is mean it can be altered, right? Dynamic, it's dynamic, right?
Dynamic, it means that it can be available and it can be removed.
So that's all.
But if not dynamic, it cannot be removed. It will be available until the end of the program.
Oh.
That's the difference between a dynamic memory allocation and static. For static, when you declare an array in the
Like
beginning,
previous
then
one.
it will be used until the end of the program.
Oh. Oh, understand. Just like we have learned before, the static one, right?
Yeah.
For the
So,
pointer and reference.
yes. If you use a pointer or array, you need a space in memory to have them throughout the runtime of the program. But if you use dynamic, you can have it and you can remove it during the runtime. If you don't want to use, you remove it and then you use another new data to put it inside the memory. And then remove it, use another new data.
So, how about the line with the value with 22? How we get the
Sorry?
20?
For
The value
this, okay.
20.
This is one kind of, you can use it like ordinary array. We don't need to use any other operator to acknowledge that this is a dynamic memory allocation. It will be the same as you use for array without the dynamic memory allocation. So this is the way how you use it. You want to put the number, put a value, you want to remove the value, you want to do the arithmetic, the logical, all you can do using the normal way of addressing it. You don't need any operator, stop, differencing, and operator, no need. Use it. Directly use it.
Declare. It's just like normal declare that.
Yes, yes.
Oh, alright. It's not so not relatable with array.
This is array.
It's array.
This is array. If you
2 dimensions.
before, array is this. This is array. If you
Oh.
want to use a static array, this is the same as using in static array. It's the same. When you want to use a dynamic memory allocation, it's the same as the static memory allocation. The only thing that we need to create this first, and we can remove it after that, after we use. But for static, we cannot remove it. It will be until the end of the program when we choose to use a static array.
Oh, alright. So we delete still it will be C4 with 22, even though we delete C because it was static.
Okay. Do you understand about array?
I do understand, but array more to like actually with this coding, I can understand how I can imagine the value how the coding is, the output is.
Okay, okay. Okay, never mind. I'm going to continue first. Maybe after this you have some idea of what we mean by dynamic memory allocation and array. Okay, if you still don't understand after we continue, then you can ask me back again.
Oh, alright.
Okay.
Alright.
Because this is still not clear. This is just to, okay, you are declaring some part of the memory in this array, 3D array.
3D array.
Then you can use it. How to use? You use it as a normal array. This is example. We use for the first dimension, location, location 5, location 6, location 12. Put this value.
22. Oh. Ah.
Okay, let me continue first, and then if you don't understand, then we can discuss it back again.
Alright. Thank you, sir.
Okay. We have discussed actually the dynamic memory allocation for using the C++. So in the C programming, it is a bit different. Okay. It is using the function malloc. If you want to create a dynamic memory creation array, then you use malloc. There are some other function also, calloc also can be used, but in our scope of this course, we use only malloc. And in order to destroy or to remove it, we use free. But for C, I think it's a bit easy compared to C++. Later on, we are going to look why I call it about easy. This is what we mean. If there is a need to resize, free first and relocate. It means that you cannot use the same to resize. You need to free it first. You need to remove it first. Then you make another size again. Okay. If in C++, we can resize it within the same memory allocation, but also not in our scope. We are not cover that part. Okay, we not cover in detail how we are going to resize the dynamic memory allocation. Okay, for array 2D, 3D, and 4D, as usual in C also, we are going to nested. We use a nested malloc. Okay, for loops. Okay, need to be used. Okay, and to access also is going to be normal method to access. Same as static array. Okay, you can access directly like this. Okay. Okay, let me show. This is for a non-array. Okay, as I mentioned, actually, when you you don't use an array for a single, it's a kind of wasted. It's not utilized. Okay, only one value. If let's say you use integer required 4 location. Okay, only that 4 location you use, suddenly you want to remove it. So it's not really utilized. The features of dynamic memory allocation. But you can, and it's not going to be any error to have a non-array, a single dynamic memory allocation. Same as in C++, you need to use a pointer, okay, declare a pointer, and then you allocate it. Okay, how you allocate? Okay, you have, this is the syntax. Okay, you don't put any star in front. Okay, and then you just put, should be the same integer type, star, malloc, size of, in bracket, integer, and then you close the bracket. Okay, since it is an integer, it means it use 32-bit. 32-bit we refer to 4 byte. So 4 location you require. Okay, to use it, you need to put a star, and then you can use it. 1, 2, 3 means that put 1, 2, 3 integer into the location. And if you want to remove it, you just type free and put the variable. Okay, it seems look like easy to use it. Okay, class. Okay, as I mentioned, the data type must be same for all these three. This is the syntax. This is the syntax that you just follow the syntax. Okay, and then to mention that we use a pointer. Okay, then we look at one-dimensional array. Okay, how we declare, how we use, and how we remove it. Okay, as usual, in this example, actually we use double. Okay, we use double data type, and we need to declare as a pointer, okay, 1D. So this is a declaration of pointer. And then how we allocate it. Okay, in this example, let's say we allocate it 512. So it means that you need to declare a row is a double with you assign 512. Okay, so this is the way that you declare double star malloc. You need to have row multiplied by size of double. Okay, so double is 64 bit. And how you use it? Okay, this is one way. Okay, since you have row is 512, so it will have 512. This is just the random use. Okay, you put a random number inside it. So it means that you use like ordinary array. You don't need any other operator at the beginning or at the end of the variables. And how you free it? So that's why I said it is quite easy, because you just put free 1D and then you free everything. You remove everything. It's much more simple with the C++. But as I mentioned earlier, the advantage of C++, you can resize it. You don't need to declare back for another application, for example. You can resize it while you remove certain part of the dynamic memory allocation that you use. Okay, it's quite simple for remove the dynamic memory allocation. Okay, this is an example. This is the array that you create. Okay, you have from 0 until 511. So it is 512 in total. So when you run the program in the beginning, if you not declare this part, 512 part is not being used. You can use for any other purposes. But once you declare it, so it will be reserved to be used to this 1D array. So this part cannot be used. And then after you free it, so this part will be used for any other. So the resources is increased while you using. So that's why we mean by dynamic. It can be created and it can be removed during the runtime. Okay. This actually this also same as the C++. Okay, when the first and only new is executed. When you declare it, this is that you going to have in the memory. And if you can remember back in the first our first lecture, heap, it can be any place in the memory, and it's not necessary to be in contiguous. Okay, let's say you have 1D, you have 1, and then you have 2D, you can have some other part of the memory. It's not necessary to be contiguous. Okay, so in 2D, okay, for C programming language, so you need to declare first. You declare, you need to put two store here, and then you allocate. Okay, in this case, you allocate the first dimension. Okay, let's say 512. Okay. In this case, it is integer. Integer is 32-bit. Okay. And then you need to have a for loop in order to generate the second, to allocate the second dimension. And this second dimension, both of row and column, need to be declared before you write the code. Okay, before you write this code, actually, row should be declared as integer equal to 512, same as column. Okay, the rest is the fixed syntax. Okay, the rest is the fixed syntax. It will be the same. Okay, so this is for the second dimension. Okay, this is how you can use. Okay, you not necessary to have use for nested for. You can use individual value. Okay, 2D1, 2D1, 2, put a random value examples. Okay, and to remove it, to make it free. Okay, so that's why it's quite easy. To the syntax is much more easier compared to C++, because you cannot remove certain part of that particular dynamic memory allocation that you created. You need to remove the whole thing, the whole dynamic memory allocation that you use. So you just type free, in bracket, the variable name. Then you free. Okay, class. Get it? Okay, just for your, maybe give you some idea of creating a dynamic memory allocation using C. To declare, you need to put two, okay, two pointer to what we call to store. And then you need to match row for the loop. It means that in this each row you are going to create column. In this case also 512. Okay. And then okay, this is you just to use. Okay. You need to add also. Okay, in the first creation, the first dimension, you didn't put any value, only row. But the second one, you need to put integer, malloc, okay, integer store. Okay. And you don't need to put the size of function. Okay, the last call to malloc is the size of integer, not integer store. Okay, size of integer only. Okay, this is what I mean. The first, you generate row from 0 until 511. So in total it is 512. And then for each of these members array, you generate another 512. Okay, all of it. Okay, in each iteration where malloc column, each of the column, which this column is actually 512. Okay, you generate it. Okay. It means that this is the size that you are going to use dynamically in the memory. Okay. Once you generate, for example, in this variable, 2D variable, you generate this amount of memory that you use. Okay. And then you can remove it. Use for another data set, for example. Okay. Okay. This is for a 3D 3D dimension array for C. Okay, I think the syntax is about the same. Okay, it's about the same. The only thing that like 3 star here, 3 star, 2 star, 1 star, and then you have row, column, and band. Okay, we use this actually for hyperspectral picture, which being captured by the satellite. Okay, then to use it and to remove it. Okay, if you look even in 3D also, in how many dimension also, you just need one line to remove the dynamic memory allocation totally. Okay. Okay, this is, as we looked before, this is the 2 dimension. So if we have 3 dimension, then we have another 2 to 4. 2 to 4 value here. Actually, it's not 2 to 4. It should be 2 to 3. Okay, because we include 0 as the first one. Okay, until 511 for row, and then we continue for column. Okay, that's why we need loop. Okay, this is the first loop. It nested the second loop. Okay, so you can imagine a huge amount of space that being used. And the good thing is you can use this space after you do some arithmetic or whatever algorithm that you want to apply to this data, then you can remove it. can use for other data. Okay. Okay, advantage of such implementation, easy and clear to access using X, Y, Z indexing. Okay. However, need to be careful in accessing the element which they are actually continuous memory block, okay, for the same array. Okay, this is the other way to declare three-dimensional array in the C. Okay, we just use only one syntax to declare it. To allocate it. First, you need to declare it, and then you use another one to. So this is quite easy compared to use the for loop. Okay, for loop is quite difficult to remember how going to do the syntax. Okay, you have one. Okay, this is for 3D. So you have one, and then you require another syntax. Another nested loop, for loop. Okay. You can replace all of this with single line. Okay. Okay. Okay, also apply to dynamic memory allocation in C. In C also, you can use such as this. Okay, to create the dynamic memory allocation. Okay, usually in embedded platform, there are some performance hit if we use nested for loops. Okay, the solution to optimization by the compiler or manually tune the code. Okay, because it's quite, especially when you increase the number of dimension, then it becomes more complex. Okay, when you create uh, the the dynamic memory allocation. Okay, any question? Last. Because I'm sorry. Do I hear someone? Function overloading, I will continue it in next class, but I'm going to stop now. So that's why I ask you, do you understand it? Do you have any question? So just now, who's the one that asked me? CT, is it? Nor Hazah, Shahira.
Yes, sir.
So do you understand about the dynamic memory allocation?
Which one, Mellow? Or difference?
Yes, malloc or use new or delete.
Or for the coding and for the we call it how to make I understand, but the coding, just the coding, just now the coding, I
Okay,
just confused.
there are a lot being used in Vivado.
Vivad.
Uh,
Oh,
but there are a lot. But I'm not going to, because I don't have experience with Vivado. My
oh,
scope, my part is only give you some explanation about dynamic memory equation actually is the same as in Vivado or in C or C++. Because
CN
in Vivado, you can use C or C++.
if I oh, but I better use my visual because I saw YouTube got a lot of tutorial. Vivado, I think
Yeah,
I didn't use before actually.
yes, yes. Vivado because the purpose is only for the FPGA, so it's quite the setting, but the code is about the same. The only
Mm.
thing is to set it up and to carefully choose the setting. It's quite
Oh,
difficult, and you
oh.
don't have a lot of references.
Yeah, because we have a mini project. That's
Yeah,
why we have to master. Not master. Not, we have to understand this.
yes,
This mellow, and then maybe we can use in the mini project.
yes.
Mm.
So the main purpose of dynamic memory allocation is to being create and remove during the runtime. When you run, you can create it. But if you use any kind of static or stack, it is fixed.
Mm.
Means the processor need to reserve the space when you start run the program. But in dynamic, you can create it and later you can remove it during the runtime.
Because I saw one of our mini project. We have SD card, and then we have to like we key in the value, key in the data, and then we have to remove the data. I think it can be related with this coding.
Yeah, sure.
Yes, because so like we have five one row of storage there from the coding state.
Yeah, yeah. If let's say you have, for example, a picture, you want to change to become, you want to make the contrast become, you increase the contrast. So you save the picture into certain memory allocation, do
Mm-hmm.
some algorithm,
Mm.
and then you can remove it, take another picture. That is the purpose of having the dynamic memory allocation.
Oh, it's a like can be like image processing like we have RGB
Yes, yes,
and what call black white. Oh,
yes.
alright.
Okay,
I've,
and there are, I think, a lot of algorithm about the contrast already available. You can choose it and use it.
oh, okay, understand. Alright.
Okay.
Mm-mm.
Okay, any other guys? Do you have any question? Okay, so if you don't ask, then I'm going to ask you. Okay, actually, I have made the quiz. I put it in the e-learning. I not open it yet because the time to start is at 9. Okay, it's 9 o'clock. So I will open it soon. You have about 30 minutes to answer it. Okay, guys, any question? Okay, I'm going to open. Okay, guys, can you open the e-learning and check if the quiz is already available? But you cannot start it yet. I put it at 9, so it's about 2 minutes. Okay, and you have about 30 minutes completed. It is, I think it's quite simple. Okay, you don't need to attach anything. Answer directly on the website, on the e-learning. No attachment needed. Okay, no attachment needed. Just answer it directly on the e-learning. Okay, guys. Okay, you may open your e-learning and check either the quiz is already available. I have made it available. Okay, I think it's already available. Good luck, guys. If you have anything, you may post a question on the group WhatsApp. I'm going to end the meeting. And for those who Malaysian, okay, please cast your vote in this Saturday. Okay, it is important for us. Okay, and you are I consider it as a well-educated citizen. Your vote is really important, so cast the vote. And good luck for the quiz. Anything you can post to the WhatsApp group. Okay, any question? For your info, you answer the quiz on the website. You don't require to have any attachment. Okay, guys. Okay, respond to me.
Hi, Doctor. I'm Patrick.
Patrick, yes.
I want to ask you, the question asked about the red black bracket. What is the red black bracket?
Okay. Let me see
Yeah,
first.
I couldn't find the red bracket.
Okay. I understand you. I should, because this is copy. Because I'm copying from the, so you use the bracket with bold. Actually, that is because in you understand me?
Okay.
There is a bracket which put number 1, number 2 in bold. Number 3, number 4.
Okay, understand.
Okay, guys. Good luck, guys.
Sir, I hope you're still there.
Sorry.
What, this is the first time I'm attempting a quiz through e-learning. So do I input the answer into the text box?
Yes. No.
Okay.
There is a space where you can write the answer. Just write the answer in that space that been given.
It's a blank. Yeah, it's
Yes.
like this blank text
Yes.
area. Okay.
The one that you can type, you can fill it.
Okay.